Imagine looking up at the sky. You see an aircraft, a familiar silhouette against the clouds, but this aircraft is different. It has been flying for weeks, perhaps even months, without ever needing to land. It does not burn fossil fuels. It does not leave a trail of exhaust in its wake. This is not a scene from science fiction. This is the future of aviation, a future that is closer than we might think. It is a future made possible by a revolutionary breakthrough, hidden away from the world in the vast deserts of Nevada. A new age of flight is upon us, one that promises to change our world in ways we are only just beginning to comprehend. The dawn of a new age in aviation has arrived, and its light is emanating from a remote corner of Nevada. Welcome to the era of perpetual flight. What does a future of endless flight look like? Aircraft that can fly for months, not hours, persistent platforms in the sky, a constant eye in the sky, connecting and monitoring our world. At the heart is the plasma engine, efficient, powerful, and clean. The promise of perpetual motion is a promise of a healthier, boundless future. For decades, the Nevada desert has hidden secrets, testing grounds for technologies that shaped our world. Deep within this expanse, a project known only as Project Horizon took shape, shrouded in secrecy. Whispers spoke of strange lights and ambitious ideas. Aircraft that could stay aloft indefinitely. Now the world is beginning to see what was achieved in the Nevada desert. The journey toward the plasma engine began not in a laboratory, but in the realm of pure imagination. What if an aircraft's engine could function like a miniature star, harnessing plasma and use air as its only fuel? For years, it was just a dream. Impossible, impractical. But a few persistent minds refused to let it fade. They became the architects of a new era, turning imagination into the engine of the future. The Nevada plasma engine wasn't the work of a single genius, but a diverse, multi-generational team. Physicists, engineers, and material scientists united their expertise, forging a culture of collaboration and relentless curiosity. Though their names remain unknown, their legacy will soar across the skies, a testament to their brilliance and shared vision. At the front of the plasma engine is a simple-looking intake, but what happens inside is extraordinary. Here, the engine transforms the air we breathe into a powerful propellant. Air flows into the ionization chamber, where intense microwave energy strips electrons from atoms, creating plasma, the fourth state of matter. Plasma is found in the sun, lightning, and nebulae. The beauty of this system is that its fuel, air, is everywhere in Earth's atmosphere. This liberates the aircraft from the limits of range and endurance, setting the stage for the next step, generating thrust. Once air is transformed into superheated plasma, the challenge is to harness its energy for thrust. Powerful superconducting electromagnets generate precise magnetic fields inside the engine's chamber. No moving parts, just invisible forces at work. These fields act like an invisible hand, guiding and accelerating the plasma rearward at astonishing speeds. The magnetic nozzle forces plasma out the back generating powerful continuous thrust without friction or wear. This elegant silent method is the heart of the plasma engine's revolutionary design. A perfect marriage of physics and engineering. Plasma engines demand immense energy. Ionizing air and accelerating it with magnets takes more power than any battery or generator could provide. Project Horizon's solution: a compact, self-sustaining onboard energy core, often compared to a miniature contained star. Encased in advanced radiation-absorbing materials, it powers the engine for months, eliminating refueling and transforming flight logistics. The power of a star, safely contained, turns the dream of perpetual flight into reality. The plasma engine's core pillars, ionization, magnetic acceleration, and the energy core, are remarkable on their own. But the real breakthrough is their seamless integration and control. An advanced AI control unit acts as the engine's brain, constantly monitoring and adjusting every system for peak performance and safety. It manages energy flow, thrust, and even heat, using cryogenic cooling to recycle waste heat and boost efficiency. This holistic, intelligent system is what makes the plasma engine revolutionary, robust, efficient, and safe, all working in flawless concert. The Nevada plasma engine is set to revolutionize commercial aviation. Passengers will enjoy unprecedented convenience, connectivity, and comfort. Ultra-long-haul flights, like New York to Perth, will become non-stop realities with smoother, quieter cabins. Airlines can offer direct routes between more cities, opening new markets and reducing fuel costs. Aircraft design will evolve with wider cabins and innovative shapes for comfort and efficiency. The plasma engine promises a future of faster, more direct, and passenger-focused air travel. The plasma engine is set to revolutionize global logistics and science. Imagine fleets of autonomous cargo aircraft circling the globe, delivering goods and humanitarian aid faster than ever before. These aircraft could remain aloft for weeks, acting as persistent platforms for research, disaster relief, and even internet connectivity. In emergencies, they could deliver supplies and provide vital communications when infrastructure is down. The plasma engine is more than propulsion. It's a tool for discovery and a new asset for humanity, reshaping our world from the sky down. The advent of near-perpetual flight is revolutionizing defense and national security. Plasma engines eliminate the tyranny of distance, allowing aircraft to stay aloft for months and provide real-time oversight of vast territories. This persistent capability gives commanders unprecedented situational awareness and transforms global reach and power projection. Strike platforms could reach any point on Earth, loitering for extended periods as powerful deterrents. The quiet plasma engine makes aircraft harder to detect, forcing adversaries to rethink air defense. But this technology also raises new challenges for international security and arms control. The Nevada plasma engine isn't just a leap for aviation, it's a gateway to new frontiers. Its compact, high-output energy source could revolutionize our energy landscape, powering cities and remote communities with clean, abundant energy. In space, plasma rockets could make interplanetary travel faster and safer, opening the door to Mars and beyond. Advanced materials and superconducting magnets will transform industries from energy to medicine. The Nevada project is a catalyst for innovation, building a cleaner, faster, and more connected future, both on Earth and beyond. The Nevada prototype's success is just the beginning. Turning a handcrafted engine into a mass-produced, reliable power plant brings immense engineering challenges. Scaling the technology means rethinking production, modularizing intricate systems, and standardizing every component. Advanced robotics and rigorous quality control are essential to ensure every engine performs flawlessly. New alloys and ceramics must withstand extreme heat and be produced at scale. Heat management, plasma stability, and instant magnetic containment response are critical. Only then can this groundbreaking engine become a dependable workhorse of the skies. Ensuring the safety of passengers, crew, and people on the ground is the greatest challenge for nuclear-powered flight. A compact nuclear source brings new safety concerns, demanding robust shielding and emergency protocols. These systems must be proven infallible through exhaustive testing. Public trust depends on preventing core breaches or radiation leaks, even in a crash. Months-long flights raise questions about passenger well-being and mental health. New designs must include exercise areas, social spaces, and advanced environmental controls. Crew training will require new skills in nuclear systems and emergency management. Electromagnetic interference must be rigorously tested and shielded. Every aspect must be proven safe before these aircraft fill our skies. The introduction of aircraft capable of near-perpetual flight will render many of our current aviation regulations obsolete, demanding a complete overhaul of global air traffic management. New highways in the sky or designated loiter boxes at specific altitudes may need to be established. This will require unprecedented levels of international cooperation and a new global framework for airspace allocation, managed by a new generation of air traffic control technology. The legal and regulatory frameworks governing aircraft maintenance and airworthiness will also need to be entirely rewritten. An aircraft that flies for a year without landing cannot follow a maintenance schedule based on flight hours or cycles. Instead, aircraft will need to be equipped with extensive self-diagnostic systems that continuously monitor the health of every component in real time. Maintenance will shift from a preventative schedule to a predictive one, where parts are replaced based on their actual condition, not an arbitrary timeline. This raises complex questions for regulators. What are the new standards for aircraft longevity, and who is liable when a component fails 9 months into a non-stop flight over the Pacific Ocean? The potential for dual-use applications, where civil technology can be adapted for military purposes, presents a formidable challenge for international law and arms control. The line between a scientific research aircraft studying atmospheric conditions and a military surveillance platform monitoring ground activity is dangerously thin. Nations will need to establish new treaties and verification regimes to ensure that these persistent platforms are not used for aggressive intelligence gathering or to upset strategic balances. The question of how to regulate a privately owned cargo plane that has the inherent capability to stay airborne over a conflict zone for months will undoubtedly spark intense international debate about sovereignty and the weaponization of the skies. Finally, the well-being of the crew on these ultra-long-duration missions will necessitate new labor laws and international standards. How many hours can a pilot be expected to be on duty during a 3-month flight? What are the requirements for rest periods, crew rotation, and onboard living conditions? Aviation authorities and labor organizations around the world will need to collaborate to create a new set of rules that protect the human beings operating these extraordinary machines. Before the first commercial passenger boards a plasma-powered flight, a vast and complex web of new laws, regulations and treaties must be woven to ensure that this revolutionary technology is integrated safely and responsibly into our world. The Nevada plasma engine marks a new era in aviation, a testament to human ingenuity and our drive to break boundaries. Born in the desert, this breakthrough shatters the chains of fuel dependency, unlocking the skies for cleaner, quieter, and more capable flight. By turning air into propellant, the plasma engine redefines what's possible, connecting cities, reshaping economies, and protecting our planet. The glow of ionized air signals a new dawn, one where flight is sustainable, efficient, and truly limitless. The plasma engine's promise is dazzling, but the journey from prototype to global adoption is just beginning. Engineering challenges, safety standards, and new materials must all be mastered. Earning public trust and meeting rigorous regulations are essential. Yet, the vision of perpetual flight is too powerful to ignore. The Nevada breakthrough has shown the impossible is now within reach. The plasma engine is a beacon, illuminating a future where our skies are limitless.